All right, we're back. We are on page 9 of math analysis, and we are talking about, what are we talking about? We're talking about principal coterminal angles and rotations and degrees and radians and all kinds of stuff, to be honest. So this problem here says, write a function that finds the value of n from the table on the previous page and another that finds the value of a directly. Okay, so we actually already did this sort of in the last video, if you watched it through to the end. I know that page was a slog, man. First of all, I had to like remake any video that involved the calculator. I had to like remake it twice, so that was fun. And then also there's just like a lot to do. Like there's a lot of information on there. Once you're good at it, you'll look back at that page and think, why did this ever take me more than like 5 minutes to blow through? But like at the time, basically all of math analysis is like that. Actually, you like keep learning and getting so much better at the stuff that you were learning that you look back on it and you're like, why did I ever find that so hard? But like hard, that was weird. But you know, that's the way learning works, really. So we already figured this out. So we said that n. So let's do one for degrees and one for radians. So I'm going to call the one for degrees. I'm going to say nd of x, and then we have to, because of the calculator, we have to do colon equals. On paper, you don't write that, right? When you're just writing it on paper, you would just say nd of x equals. But for the calculator, we have to do this, and then we'll say floor of x over 360. So we don't need a degree symbol. So this will find us n in degrees. And then once we know n in degrees, we can find a in degrees by using this function. So this is like something that maybe you haven't done all that much of, but I'm going to say a, is that an a? A in degrees of x, then colon equals. So I want to take the angle that I'm dealing with. So I'm doing what I've been doing on paper, just trying to write a function that does it, minus. So I could definitely say floor of x over 360 and then times 360, but it's easier, better probably, to just use the function we already defined. So I'm going to say this and then times 360. So this should work. We're going to check it on the calculator, but that should work. Now to change it so that it works in radians, so let's say n in radians of x, colon equals, it's going to be floor again, and then we want to do x, not divided by 360 because we're in radians, so divided by 2 pi. You want to really make sure pi is in the denominator, so use the fraction template, and we're going to do that. And then a in radians is going to be equal to whatever x is minus n, so n in radians of x, times, what's a revolution? It's 2 pi. Okay, so these should work. And then the next problem, we're supposed to use those, so that's good. So let's do that. So let's switch and calculator. All right, let's see. So I'm just going to start a new calculator page, hopefully like a whole new calculator document. Hopefully this doesn't mess it up, hopefully. So nd of x, colon equals. Remember, colon equals for you is control and the templates button. Fastest way to get it. And then floor, I'm actually just typing x over 360 using the template, and then a in degrees of x is going to be x minus the floor function, like, you know, the thing we just made. So I'm just going to press the var key and get it of whatever x is, and then times a revolution in degrees is 360. So, and when you make these, you should always test them out, right? So nd of 361 should be 1. And I know that AD of 361 should be 1 because you're 1 degree over 360. So I think that that's working. Now I want to change these without retyping everything. So I'm going to go up, just paste this down. I'm going to change the D into an R for radians. And I'm going to change the 360 into a 2 pi. You have a pi key, which you should use. I find it faster to type. And then let's change, nope, let's not change done into something. What does that even mean? We're going to change this. So this needs to be in radians. This needs to be R for radians. And then instead of 360, we're going to use 2 pi. Okay, so maybe we're not as familiar with radians, so like something bigger than 2 pi. So maybe if I go pi over 6 past 2 pi, that would be Actually, you know what I can do? I can just do 2 pi plus pi over 6, right? And so it should give me 1 because it's definitely 2 pi past pi over 6. And it did. And then if I do AR of it, 2 pi plus pi over 6, it better give me pi over 6, which it does. Okay, so it works. So that's really good. In the notes, it's telling me to, so let me just string these together for you because you can do kind of a neat thing. So if you want to find like we want to find A and N in degrees. Okay, so this is weird. I'm going to type DE. So you see how when I typed AND, it suddenly went from italicized to justified? That means there's a stored function with that name. We don't want that. So what I'm going to do is just put EG, degrees of X, colon equals. And then you can do so many things with the calculator. So one of the things is you can define a function to kind of like output a list. So for this, I'm going to have it output what A in degrees of X is, comma, what N in degrees of X is. So now, if I give this, let's give it 361, right? So it should tell me that A, the principal coterminal angle, is 1, and N, the number of rotations to get there, is also 1. So it should give me 1, 1, and it does. That's very cool. And so now we can use that. So in the notes, it says 77562. Also, if you are looking at the notes right now, I gave you more space to do this particular problem than I gave you to do like anything else in the notes all year. So this is my degree version of this. So I'm actually gonna, I'm just gonna jot that down for a second here. So A is 162 and N is 215. That's a lot of revolutions. I'm gonna paste this down and change it a little bit to get the radian version. So AN rad. Okay, so this should be in radians. This should be in radians. So just use things that you've already put in because it'll save you so much time. So let's try it with, what do we know? So, oh, let's do the, so let's do 2 pi plus pi over 6 again, which is definitely 13 pi over 6. I don't know why I didn't do the math on it before. So yeah, principal coterminal angle is pi over 6. 1 revolution away from that, you will get 13 pi over 6, which is kind of what we fed it. So let's see. So I can just type them. You should love the vars key. Like press it all the time, see what's in there. It's really one of the like underutilized by students keys on the calculator. It's purely there to save you time. I mean, that's why that key exists. So here, I would say that, I'm gonna write this down. A is 4 pi over 15, and then N, the number of revolutions that you make to get there, to get to the final angle, is 86 full revolutions. All right, let's go back to the notes and see what we got. So we did a lot here. I mean, we've stored some things on the calculator. Like, you gotta get good at using the calculator. And the process of getting good at using the calculator involves using the calculator. So if someone tells you to use your calculator, use your calculator. So I think what I'm gonna do is I'm gonna cut this here and come back in the next one and do the rest of this page, because the problem at the end, I don't know, it might take a little while and I don't want this to be an infinitely long video. I know that no video is infinitely long, obviously, I don't need you telling me that, but anything over 15 minutes feels infinitely long to me. So I'm gonna stop this here. I'll be back and we will finish this page. So I will see you there.